All right, here we are with number 6. Now, I actually do kind of like number 6 in hindsight, but when I did it, I was not all that much a fan because I didn't really understand what it was asking. But let's go through this and we'll see what happens. So when I arrived at the railway station yesterday evening, I noticed that the clocks on platforms 1 and 2 were displaying different times as follows. A few seconds later, they both changed simultaneously to this number. After watching them both for several minutes, I concluded that the last digit of the platform 2 clock was faulty, with one element that was permanently on and one element that was permanently off. For how many minutes altogether during each hour are the displays on both of these clocks identical? So the thing that I didn't like about this problem initially was one element on, one element off. I really didn't know what that meant. However, in retrospect, if we look at each of these sets of digits, so let's look at this last digit. This has 7 elements. We have horizontal, side, side, horizontal, side, horizontal, side. Altogether, there's 7 components there. So let's draw out all of the components, or there's 7 potential components. Let's draw out all of the components for each of the 6 and the 9, because those are the things that we really care about. So we have 6, the 9. Okay, so let's see what's similar. Okay, so we have the top horizontal, this side, middle horizontal, here, 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 here. So we need to figure out which parts aren't in line with each other, and clearly that's this one and this one, as well as this one, this one. I don't really like that. Let's see if this works. Nope. Now let's just use the same color there. So these are the 2 components that aren't lining up perfectly well. So if we know platform 1 is correct and platform 2 is wrong, that means this one is supposed to be blank, but it's not. This one is supposed to be filled, but it's not. So what that tells us is this element is always on. This element, it's a fancy LW, always off. And so what they want to know is how many minutes altogether in each hour are the displays on both of these clocks identical. So what you're going to have to do is figure out where each of these are accidentally correct. Okay, so what we're going to want to do, 1, 1, we have 2, 3, 4, 5, 6, 8, 9. So we're going to go through each of these to see, okay, is this bottom left one off? Is this top right one on? And then when that's the case, we know that we have one that works. So these are all of the possible numbers for the last digit, as well as 0. There we go. Okay, so is this one on? Yes. Is this one off? No. Is this one on? Yes. Is this one off? Yes. On, off, that's good. On, off, that's good. Off, off, that's no good. Off, on, that's no good. On, off, on, off. So altogether, that's 1, 2, 3, 4, 5 times out of the 10 possibilities, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible digits that can be in that last place, which means 5 out of 10 are correct, which means 30 minutes is going to be your answer.